Hello everyone and welcome back yet another lecture of SM online class, and today we are going to start a new chapter. Okay, we have already completed exercise 12a. Okay, now we move to on second chapter, and the chapter name is what? Dot product. Okay, dot product, and here there is the content for today class, that is definition and geometrically interpretation of dot product and properties of dot product. So student, in the first class we studied that addition subtraction of vectors. Okay, but when two vectors are multiplied, that is two non-zero vectors are multiplied. Okay, that means one is, that is dot product, and another one is, that is cross product. Okay, so if the result is dot product, if the two vectors are multiplied and the result is dot product, if the result is scalar, then it is called a dot product or scalar product. Or if the result is a vector, then the product is known as vector product. Okay, or cross product. Okay, so in this chapter we studied about dot product. Okay, so let us start. Now, if two non-zero vectors, okay, let us suppose this is vector A and this is vector B. Here vector A and vector B are what? Two non-zero vectors. Okay, and here they are joined by tail. Okay, that vector A is connected with tail of vector B, so it makes an angle theta. Okay, then what is the dot product of vector A and vector B? Okay, and the dot product of vector A and vector B, okay, if vector A and vector B are two non-zero vectors, okay, then dot product is given by, dot product is denoted by, okay, then dot product is denoted by vector A dot vector B. Okay, then dot product is denoted by vector A and vector B, and here vector A and vector B makes an angle what? Theta. Okay, vector A and vector B makes an angle theta. Okay, and dot product is dot product of vector A and vector B. Vector A and vector B is defined as okay, that is vector A dot vector B equal to product of magnitude of A into product of magnitude of B and cosine of angle between them. Okay, cosine of angle between them. This is the dot product of two vectors. That is vector A dot vector B equal to product of magnitude of A into product of magnitude of B into cos theta. Okay, now if this is the definition, okay, that is vector A dot vector B is what? product of magnitude of A into magnitude of B cos theta. Here we write here product of magnitude of A, that is A into B cos theta. Okay, it is also right here. Okay, now this is the product of magnitude of A is also a scalar and product of B is also a scalar. Sorry, magnitude of A and magnitude of B is also scalar, and theta is a real number, so cos theta is exist and cos theta is also a scalar. Okay, then the product of three scalar is also a scalar. Okay, that's why A dot B is called scalar vector also. Okay, product is scalar. Product is scalar, so it is called scalar product. Okay, scalar product. That means dot product is also known as what? Scalar product. Dot product को हमें कौन scalar product हिसाब से हमें कही परिबा. Dot product means scalar product. Okay, now come to second point. If either vector A or vector B is a zero vector, if either vector A or vector B is a zero vector, then what happens? Okay, let us see. That means if vector A equal to zero vector or vector B equal to zero vector. In this case, what happens? Let us see. So here we know that if vector A and vector B are two non-zero vectors, then theta is exist. Okay, if vector A and vector B are two non-zero vectors, then theta is exist. Okay, let us consider. Suppose this is vector A. Okay, and suppose vector B is equal to what? Zero vector. Okay, let us vector B is zero vector. Means zero vector has arbitrary direction. Zero vector has what? Arbitrary direction. So in this case, we cannot define the value of theta. Okay, in this case, we cannot define the value of theta. Okay, let us take, suppose this is vector B, suppose. Okay, and let us vector A is a zero vector. That means a zero vector has infinity direction. Okay, that means in this case also we cannot define the value of theta. So in that particular case, if vector A equal to zero vector or vector B equal to zero vector, then vector A dot vector B is equal to what? Zero. Okay, because magnitude of A into magnitude of B, cosine of angle theta is not defined. But if any two vectors are zero vectors, that means the magnitude is what? Zero. Then 0 will multiply of something into 0, that is also 0. So A dot B is equal to what? 0. Vector A dot vector B is equal to 0 if vector A equal to 0 or vector B equal to 0 vector. Okay, this is an important case. Now come to the second point, geometrical interpretation. Okay, geometrical interpretation, that means हम geometrically dot product of meaning का कौन हमें बाहर करेगा. Okay, let us consider this is vector A. Okay, and this is vector B. B, and this is suppose O. Okay, and if we draw a projection from vector B on vector A, that means projection means what? If a perpendicular drop from vector B on vector A, that means projection, and let it meet at the point M. So here OM is called what? Projection of vector B on vector A. Here OM is called what? OM equal to projection of vector B on vector A. Okay, and let this angle theta. Now this is vector B. Okay, now come to the point. Here let us, this is vector B and this is vector A and this is O, and if we draw a projection from vector A on vector B and let it meet at the point N, then ON is called what? ON equal to projection of, okay, projection of vector A on vector B. Okay, projection of vector A on vector B. Now in this case vector A dot vector B is defined by what? Magnitude of A into magnitude of B into cosine of angle between them, that is cos theta. Okay, and in this case that is vector B dot vector A is equal to what? Magnitude of B into magnitude of A cosine of angle between them, that is cos theta. Now point is that in this right angle triangle, okay, in this right angle triangle, here suppose this is suppose B, okay, here, and this is suppose A. Let us check. Okay, now here in this right angle triangle cos theta, the value of cos theta is what? The value of cos theta is OM by magnitude of OB. Okay, OM by OB. Clear? Or implies that the value of OM is what? The value of OM is OB cos theta. Okay, OB cos theta, and OB, that means what? Length of OB, that means what? Magnitude of vector B. Okay, it is equal to magnitude of vector B and product, that is cos theta. Okay, and in this case here cos theta is given by what? That is ON by OA. Okay, ON by OA, or implies that ON equal to what? That is OA cos theta. Okay, ON equal to OA cos theta, and OA length, that is length of OA, that is magnitude of vector A. Okay, magnitude of vector A. Now if we put the value of magnitude of B cos theta in this equation, that is A dot B. Okay, then what happens? See, if we put the value of OM in this equation, okay, in this equation, now that is vector A dot vector B equal to what? Magnitude of B cos theta, that is what? OM. Okay, that is equal to magnitude of vector A into OM. Okay, now in this case here vector B dot vector A is equal to what? That is magnitude of A cos theta is what? OM. So magnitude of vector B into OM. Clear? Now come to the point. That is OM is called what? Projection of vector B on vector A is equal to, here right here I am, vector magnitude of vector A into projection of of vector A on vector B. Projection of vector B on vector A. Sorry, projection of vector A on vector B. Okay, that means हम पहले कौन A dot B equal to magnitude of A into projection of vector B on vector A. Okay, and in other cases it is what B dot A is equal to what product of magnitude of vector B into projection of vector A on vector B. तो हमें कंक्लूड रे कोन माने हमरो माने कंक्लूड ता कोन आसला कंक्लूजन ता that is dot product of two vectors. Okay, dot product of two vectors is also defined as what product of magnitude of one vectors and projection of other vectors on it. Again, dot product of two vectors is defined as what product of magnitude of one vector and projection of another vector, that is vector B. Okay, projection of another vector on it. Okay, same dot product of two vectors is defined as what product of magnitude of one vector and projection of another vector on it. Now I write the definition, that is projection of dot product of two vectors is defined as the product of magnitude of product of magnitude of one vector and projection of another vector on it. Okay, this is all about semantical interpretation of dot product. Okay, now come to the third point, that is properties of dot product. Okay, now that is properties. The first property is that dot product is commutative. Dot product is commutative. Okay. Dot product is commutative. That means what? Vector A dot, vector A dot vector B equal to vector B dot vector A. Okay. Second property, that is dot product is distributive. Over vector addition. Okay, over vector addition. That is vector A dot vector B plus vector C equal to vector A dot vector B plus vector A dot vector C. This is left distribution. This is called left distribution. Okay, and vector b plus vector c dot vector a equal to vector b dot vector a plus vector c dot vector a. This is right distribution. Okay, now this is the main important two properties of dot product, that is dot product is commutative, that is a dot b equal to b dot a, and another one is dot product is distributive over vector addition, that is a dot vector b plus vector c equal to a dot vector b plus vector a dot vector c, that is left distribution, and vector b plus vector c dot vector a, that is vector b dot vector a plus vector c dot vector a, that is right distribution. Okay, so in this class we studied definitions, geometrical interpretations and properties, and proof of these two properties. Okay, proof of these two properties are discussed